trigonometric ratios. They're usually called like primary trig ratios or something like that, and it's very common for them to call it this little acronym, so Ka and then TOA. And the reason they've given you these letters is just kind of help you memorize what the ratios are equivalent of. Okay, so very first thing we got to know is that with any of these primary trig ratios, we have to be using right angle triangles in order to use them to solve sides and angles. If they're not right angle, we can't actually use these primary trig ratios. They don't help us. So going on the assumption that all of these are right angle triangles. Okay. The next step we want to do is actually learn how to kind of name the triangle. Okay. And I guess we should write down what each is equal to. So stands for sine, and you usually put this symbol here, theta, and it represents an angle. You could call it x, y, any variable you want. This is just the common symbol they use in math to represent an angle. Is equal to the opposite side of the triangle over the hypotenuse. EUSC, I think that's how you spell that. Okay. The cos theta or cosine theta, so of that angle is equal to the adjacent side, G-A-C-E-N-T, excuse me, over the hypotenuse. Let's see. I know that's very illegible. And, excuse me, the last one is TOA, tan theta, is equal to the opposite over the adjacent. Okay, so they kind of cover all their bases here with the possibility. So the very first one I'll kind of show you sine, and we're actually going to have the same triangle every single time. What I'm going to do is we're going to call the top left corner, so this one here, we're going to say that's the angle we're working with. Okay, and if that's the angle we're working with, okay, and actually maybe we should define this first. The opposite of any right side of a triangle, so if you have a right angle, the opposite is the hypotenuse. It's the longest side. It's always opposite of the 90. So in all of our instances, I'm just going to use the letter, this will be our hypotenuse. This never changes this fact, okay? Now, depending on what angle we're dealing with, that's going to make some changes, okay? So if the angle is the top left, that means that this is the opposite side, and that this is the adjacent side, okay? Because it's touching it. There's technically two of them touching it, but one of them's a hypotenuse, so that kind of like takes precedent, okay? If, say this is the angle, same triangle, but we want to find this angle instead, well, then this becomes the opposite side, which was previously the adjacent, and this becomes the adjacent side, which was previously the opposite. Okay, and finally, we can't really do it with this one here. Okay, so you're either looking for one angle or the other. Okay, so with that being said, let's give it some values. We'll call it 3, 4, 5, maybe 3, 4, 5. We'll say those are the distances around. I don't think that's an impossible triangle. So if that's the case, and I got to set up my primary trig ratios, okay? Let's say it's from the top left angle, okay? Which number would then be opposite? What would be opposite of this?
Of that?
Of the theta.
The 4.
Yeah, the 4, good. So that's opposite. This is our opposite side, which means, and of course this is already our hypotenuse, already written it. What is our adjacent side?
The 3.
The 3. Okay, so that's our adjacent side. So now that we know that, we can set up all the ratios for this. The first one I think was we did sine. So sine theta is equal to opposite, which is 4, over the hypotenuse, which is 5. So that's our ratio. We've now just set up our ratio. If it was cos, it'd be cos theta is adjacent over hypotenuse. So you kind of have to have it memorized, and I can zoom up a little. Adjacent over hypotenuse. Well, the adjacent is the number 3. And the hypotenuse is still 5. And then tan theta is the opposite over the adjacent, which is 4 over 3. Okay, so those would be the 3 ratios. Let's say we change that. Let's now say, clone. Take this triangle. So it's the same triangle. I literally just cloned it. Let's say the measurements are the same, 3, 4, and 5. Let's say we're now looking at this angle. Okay, what is now the opposite side?
3.
3 is opposite. What is now the adjacent side?
4.
Yes, 4. And what's 5?
The hypotenuse.
Yes, that's good. Adjacent, and this is the hypotenuse. So now, if we set things up, sine theta is 3 over 5. Okay, we're still in the same triangle, but sine has now changed. The ratio has now changed depending on which angle we're referring to. Okay, cos theta,
4.
yes, 4 over 5. And tan theta is now 3 over 4. And if we kind of look to our previous ratios, get them all on the same page, yeah. You don't have to have this memorized or anything like that, but you'll notice that sine now became the new cos because we switched angles.
Yeah.
Cos now became the new sine, okay, and tan was just the inverse of the radical, okay. So that's kind of how you set up primary trig ratios, and that's like the very, very first step to doing any of this stuff.
Yeah.